For this integral, the first thing we recognize, or should recognize, is that we have a rational function where the degree of the numerator is greater than or equal to the degree of the denominator, which means that we're going to do long division. So I'm going to go off to the side and do some scratch work here first. We're going to go ahead and do that long division. X cubed minus 2 divided by x plus 2. So x cubed divided by x is x squared, and then x squared times x plus 2 is x cubed plus 2x squared, and we subtract that. Okay, so the x cubed cancels. We don't have an x squared term up here, so we just have minus the 2x squared. And then we have this minus 2, and there's nothing down here to combine it with, so minus 2. Okay, and then we do it again. So negative 2x squared divided by x is negative 2x. And then we multiply negative 2x by this divisor, so negative 2x times x plus 2 is negative 2x squared minus 4x. And then we subtract. Okay, the x squared term cancels. There's no x term up here, so we just have minus negative 4x, which is 4x. And then negative 2 minus nothing is negative 2. And we'll do it one more time. 4x divided by x is a positive 4, and multiply the 4 by the x plus 2. So we have 4x, and then 4 times 2 is 8, and we subtract. So the 4x's cancel. Now we have negative 2 minus 8, which is negative 10. And since that has a lower degree than x plus 2, we're done with our division. So now we are integrating from 1 to 3. We have this quotient, x squared minus 2x plus 4, and then the remainder, so negative 10 over the divisor of x plus 2. Okay, now all we've done so far is some algebra. We actually haven't done any calculus yet. We've just rewritten this integrand by doing our long division. Now this should be pretty straightforward to do. Now these first three terms, we can find the antiderivative there by simply using our power rule. So the x squared, we add 1 to the power, divide by the new power, so we have 1/3 x cubed. Okay, antiderivative of 2x is x squared. Antiderivative of 4 is 4x. And then right here, we have a simple linear function in our denominator. So this is a minus 10, and then the natural log of the absolute value of x plus 2. Okay. Now this here is an antiderivative of this function. We've got bounds here, so we don't need plus c, but we're going to evaluate now from 1 to 3. Okay, so we plug 3 in. We get 1/3 times 3 cubed minus 3 squared plus 4 times 3 minus 10 times the natural log of 5. Okay, and then minus, and then we plug in 1. So we get 1/3 times 1 cubed minus 1 squared plus 4 times 1. Of course, I'm running out of space here. Let me go ahead and just move this over. Minus 10 times the natural log of 3. Okay, if you'd like to simplify, you can go through and do that. This is 1/3 times 27, which is 9 minus 9. That's nice, those cancel. Plus 12 minus 10 natural log of 5. And then we'll distribute this minus through. So we have minus 1/3, and then plus 1, minus 4, and then plus the natural log of 3. So we can combine our constants. We've got 12 plus 1 is 13, minus 4 is 9, and then we have 9 minus 1/3. So 9 minus 1/3, that's 27/3 minus 1/3 is 26/3. So we have 26/3. And then to combine these two natural logs, we can if we'd like. I'm not sure that it's actually worth it. I'm just going to leave it as minus 10 natural log of 5 plus 10 natural log of 3.